Today we're going to talk about special types of linear systems. So far we've learned how to solve linear systems, and we learned how to solve them by using graphing, substitution, and elimination. But today we're going to look at some special types of linear systems. So the first one I want to look at is when we have a linear system that has no solution. Okay, so I'm going to look at the equation 3x plus 2y equals 10, and then we're going to look at 3x plus 2y equals 2. Now, I want you to notice, if I were to try to solve these, let's just say by elimination, and change all the signs, we would see here, this would cancel, become a 0, and then 10 minus 2 equals 8. That is not a true statement, so therefore we would know for a fact that we had no solution here. Another way is I can graph them and take a look at them. Now you can easily put this in your graphing calculator, but remember, we have to get y by itself. So I would say, okay, 2y is equal to negative 3x plus 10, divide everything by 2, and y is equal to negative 3 over 2x plus 5. And then our second equation, we would have 2y is equal to negative 3x plus 2, divide everything by 2, and we get y is equal to negative 3 over 2x plus 1. So here are my two equations. So I'm going to take the first one, 1, 2, 3, 4, 5. We're crossing the y-axis, and we see our slope is negative 3 over 2. So that means I go down 1, 2, 3, and over 1, 2. And there is my graph. Okay? Now for my second equation, my y-intercept is at 1. Okay, so that means I'm going to go down 1, 2, 3, and over 1, 2. You will notice the two lines are parallel. They never intersect. And if you remember, the intersection is our solution. So in this case, this is when we would have no solution. Okay? Now we're going to look at one when I have infinite, or a system where we have an infinite number of solutions. Okay, so here we will have x minus 2y equals negative 4, and y equals 1/2 x plus 2. Now this was kind of easy to be able to identify if you're graphing it. What I'm going to do is set both equations to equal y. This one's already in y-intercept form. However, on this one, we do have to change it around. And I'm just going to say, okay, negative 2y equals negative x minus 4. And then we divide everything by negative 2. And we're going to get y is equal to positive 1/2 x plus 2. What do you notice? They are the very same equation. So when I graph them, we see here we're crossing the y-axis at 2, and my slope is 1 over 2, which means I go up 1 over 2 for both, and they're the same line. Okay, also, let's look and try to solve this by substitution. We see here y is equal to 1/2 x plus 2, so we're just going to sub it in for this y value here. 2 times 1/2 x plus 2 equals negative 4. So I'm just going to use distribution. 2 times 1/2 would just be 1x plus 2 equals negative 4. Oh, excuse me, plus 4 would be negative 4. Actually, it's going to be negative because I'm multiplying by negative. Sorry. We see that the x's will cancel. We see here that negative 4 equals negative 4. Therefore, they're the very same value. That's another way by using substitution here, or elimination, and one side equals the other side. Notice when there was no solution, we had 0 equals 8. So that's not a true statement, but this is a true statement. And the way we would answer this is that I have an infinite number of solutions, or you can just say infinite. Because every x of y value will be satisfied in both equations here. Okay, now, what I would like for you to do is stop and work the guided practice on page 460, numbers 1 and 2. And I want you to tell me if we're going to have an infinite number of solutions or no solutions, and then explain why. Okay, the board's messy, but I think we can still do this. Let's go ahead and take a look at our first equation in the guided practice on page 460. Okay, so with our first equation, we have 5x plus 3y equals 6, and then we have negative 5x minus 3y equals 3. Well, if I use elimination, this will cancel, this will cancel, so we have 0 is equal to 6 plus 3 is 9. Not true, no solutions. I'll just put NS for no solution. Now for number 2, we have y is equal to 2x minus 4 minus 6x plus 3y equals negative 12. Now here I'm going to use substitution. Okay, so we're going to take this and fill it in for the y value here. Negative 6x plus 3 times 2x minus 4 equals negative 12. That would be 6x, negative 12, negative 12. The 6x cancels and we get negative 12 equals negative 12. Infinite solutions. Ah, yes, so that'll work too. Okay, I think that's all we're going to cover. One thing I just want you to look at very quickly, if you'll look over on page 462, we see here that if we have one solution, our graphs will actually cross in one place. Okay? If I have no solution, our graphs will be parallel to each other. Their slopes, if we put them into y-intercept form, the slopes will always be the same. So the slopes will always equal in this case. And then of course with infinite number of solutions, we just have one line. Because the lines kind of lie on top of each other. They are the same line, so we'll have an infinite number of solutions. Okay?